Today we're going to take a look at section 1.4 linear equations, and as we get started what we're going to take a look at first is slope. So slope, or the steepness of a graph, is defined as taking an ordered pair x1, y1 and x2, y2, and often the letter that's used is m for slope. And what we do is we take y2 minus y1 over x2 minus x1. Of course, it's important that the y values are on top, the x values are on bottom, and it's also important, as you see on this one, that the subscript of 2's line up. Oh, and I typoed one right there. And the subscripts of 1, we'll fix that one right there, line up. So that's how those should look. So y2 minus y1 over x2 minus x1. Similarly, you could write this as y1 minus y2 on top, as long as you do x1 minus x2 on bottom. And then sort of another way that I'm sure you have seen this described before is rise over run, more of a conceptual perspective of what's going on. All right, so we're going to do an example. We're going to find the slope of the line containing these 2 points. So we're going to find m. And I usually just let the second term be my x2, y2, and start with that. You don't have to. You can start with the first one if you'd like. So we're going to take the second y value, which is negative 3, minus the negative 1 in the first ordered pair, over 5 minus the 2 in the first ordered pair. So the first one, of course, is negative 3 plus 1 on top, and 5 minus 2 is 3. And then negative 3 plus 1 would be negative 2. So we have a slope of negative 2/3 for our first example. We're going to turn into the run. Same directions. We have the ordered pair 7, 3 and negative 10, 3. So we calculate the slope. The second y value is 3 minus the first y value, which is also 3. The second y value, x value, which is negative 10, minus the first x value, which is 7. And we happen to get a 0 on top and a non-zero value on bottom. Of course, 0 divided by negative 17 would be 0. And we encountered this in our last lesson in section 1.3, that this is a zero slope, and a zero slope is a horizontal line. So it doesn't ask us to identify that, but I do want you to recognize it when you see it. This is talking about a horizontal line. All right, and then on number 3, when we calculate the slope, the second y value is negative 3 minus the first y value, which is 9, over the second x value, which is 4, minus the first x value, which is 4. Negative 3 minus 9 would be negative 12, over a denominator of 0. And please do not write down that this value is 0, because it is not. Negative 12 divided by 0 is what we would consider undefined. Division by 0 is not a quantity that exists. It doesn't make sense to talk about it. An undefined slope means that you have, just like we talked about again in the last section, a vertical line. Again, it doesn't ask that on these problems, but you should be thinking that when you recognize, or when you see the undefined slope, you should recognize that fact. All right, there are 3 forms of linear equations, or equations for lines, that we're going to take a look at. The first one is called standard form. Standard form for a line we've seen a couple of times now is ax plus by equals c. A, b, and c are real numbers. While some of them can be 0, the a and the b both cannot be 0 for it to still be a line. Point slope form of a line. This is the slope m through a point x1, y1. And this equation looks like this. It's y minus y1 equals m times x minus x1. And so what you see present in this form is you see the slope right here, and you also see the ordered pair x1, y1, kind of where I highlighted there. So you have a point and a slope. And then the third form of a line is called slope-intercept form. In this one, it's easily identifiable, the slope m and the y-intercept, which is 0b. And the form of this line actually looks like y equals mx plus b. Now, in most cases, when we work with lines, we eventually get them to look like the third form, the slope-intercept form. And part of the reason we do that is because they're easy to graph from that form, either by hand or with the calculator. So we like to solve for y. But there's nothing wrong with the other two forms of the lines. All right, so let's do an example. Find the equation of the line through the given points. And in some sense, the fact that it is the equation, that's fine. There is only one equation, but there's many forms of that equation. Unless you're given instructions otherwise, typically speaking, you're going to write it into the slope-intercept form. That's the third form over here, y equal mx plus b, okay? So that's kind of going to be our default. Now, in order to do any of that, though, you need the slope. That's a non-negotiable. And then you either need the y-intercept, especially if it's already given, or you need a point. And again, if you have a point already given like you do here, then that's good to go. So here we have a point. Either of these points actually will work. And we first need to get the slope then to be able to use this. So the second y value is -3 minus the first y value, which is -1, over the second x value, which is 5, minus the first x value, which is 2. And of course you should recognize this. This is the exact same slope we had on number 1, same order of pairs, and we have a slope of -2/3. So using that -2/3 as our slope, we can take that as our m, and we can take either ordered pair as our point. We'll just use the first one, not because it's anything special, it's just first. So we have y minus the first y value, which is -1, equals m, which is -2/3, times x minus the first x value, which is 2, so minus the 2. All right, so y minus -1 would be y plus 1. On the right-hand side, we notice that we have parentheses that we can actually distribute this through, and so we will. So it would be -2/3 x. And then -2/3 times -2 would be positive. And remember, 2 is the same as like 2/1. So this would be 4, right, over 3. And then again, to get into y equals that point slope form, I'm sorry, the slope-intercept form of the line, we would subtract the 1 right here. So we would have y on the left equals -2/3 x. And then right here, where I have 4/3 minus 1, we would need common denominators. So I have 4/3, 4/3 minus 1, and 1 can be represented as 3/3. So 4/3 minus 3/3 would be 1/3. And it would be addition because it is minus a positive, plus a, we did -1, which left me with a positive 1/3. Let me say it that way. All right, so that is the slope-intercept form of our line. All right, again, we're going to look back at that earlier example that we had done, where we had some different slopes that we'd found. This ordered pair, 7/3 and -10/3, we had found the slope earlier. It was m equals 0. And we have a point, right, 7/3. So we're going to put this into y equal mx plus b, or get it into y equal mx plus b. So we're going to do y minus the first value for y, that I circled, which was 3, equals m, slope, 0, times x minus the first x value, which is 7. Now, of course, on the right-hand side, there's nothing because it's 0 times something. And I have y minus 3 on the left. And if I add 3, right, then I get y equal 3 as the equation of my line. It may feel a little bit funny, but if you'll remember back over here, we actually identified, and I had you write it in parentheses, that this is a horizontal line because it has 0 slope. So 0 slope means horizontal line, and it also means you have equation y equals a number. And in fact, y does equal a number 3. And it should come as no surprise that 3 is that number because notice, it's the y value in both of our ordered pairs. Y equals, in fact, 3. And we're done on that one. Now on the next one, it becomes a little bit more complicated. And the reason it does is because our slope, m, was undefined. If you'll flip back again to problem number 2, it's an undefined slope. So I can't put like m equals 0 in, because 0 and undefined are not the same thing. I can't put like m equals undefined or m equals does not exist. It doesn't make sense because it's not a numerical value. So what does it mean? Well, what it really means is I can't use the point slope form of the line. It means I have to rely upon what I know about horizontal and vertical lines. This is a vertical line, right? Hoi vux, right? The V-U-X. Vux, vertical lines, undefined slope, and its equations x equals. And if you look carefully, what does x equal in this equation? Well, it's 4, because I have two ordered pairs where x, in fact, is the value of 4. So x equal 4 is our equation for this line. We're going to do one more, one that we haven't actually found the slope for, but we're actually given the slope on this one. So it's got an ordered pair, 6, 9. Tells me I have a slope specifically of negative 1/3. So I can put this into y minus y1, which is 9, equals our slope, negative 1/3, times x minus the x value, which is 6. So I have y minus 9 on the left. Again, we're solving it for y. And then if I distribute the negative 1/3 through here, I'm going to have negative 1/3 x. And then a negative 1/3 times a negative 6 is positive. And then 1/3 times 6 would be 2. Then I have plus 2. We will add our 9 from the left-hand side to move it to the right-hand side. And we end up with y equals negative 1/3 x plus 2, and then 2 plus 9, which is 11. So this would be the slope-intercept form of our line. All right, now when we compare lines, they can actually have several different relationships with one another. They might cross, those are called intersecting, or they might do some things that are very specific. In particular, maybe they never cross, then we would call them parallel, or maybe they cross in a very special way that might be perpendicular. So two lines are parallel if they never cross, and they never cross if they have the same slope. So we could say that two lines are parallel if they have the same slope or steepness. Two lines are actually perpendicular if their slopes are negative reciprocals. In other words, if one of their slopes were 2, then the other one would have to be negative reciprocal of 2, which is 1/2. Another way of thinking about this is if their slopes multiply, get together to be negative 1. So let's take a look at a couple more examples. We want to find the standard form equation of the line. Now, standard form is what this one says, right? Standard form is that ax plus b, whoops, that was not a good b, by equals c. That's what the form of the line is. And this tells about lines being parallel or perpendicular. So we're not actually given the slope. We're not actually given another ordered pair. We're just told that it needs to be parallel to this particular line we're given. Now, according to what we've learned over here, parallel lines have the same slope. So one way to do this would be then to find out what in the world is the slope of this line. And one way to do that again is to get it into the slope-intercept form. So we're going to try to get this into slope-intercept form. We will subtract the 3x to the right. So I have negative 6y. I'm going to write the negative 3x first, just because that's the form of a slope-intercept. Okay, it's to have the x before the constant term. And then we divide each term by negative 6. On the left I get y. On the right, a negative 3 divided by a negative 6, well, it's going to be positive. And the 3's will reduce. So this 3 will become a 1, and this 6 will become a 2, because it's reducing or factoring or dividing by 3. So, and again, like I said, the negatives will divide to become a positive. So I end up with x/2 like this. Or perhaps you'd rather write it as 1/2 x, like this. And then I have negative 7, 6. I have that, although it doesn't really matter that I have that. The important part of my work here is that I've got a slope of 1/2. So since my slope is 1/2, and I have an ordered pair over here, I can use the point slope form of the line. So y minus the y value, which is 2, equals my slope, which is 1/2. Times x minus the x value, so it's minus negative 4. So I have y minus 2 equals, we will distribute the 1/2 through. So 1/2 times x is 1/2 x. And then the 1/2 over here, minus the negative 4 would be plus 4. So I've got 4 times 2, which would be positive 2. Now, you have to be careful because remember, our goal is to get it to look like the standard form of the line, not the slope-intercept form. If I keep going, I might end up giving me slope-intercept form because that's what I've been doing on the last problems. In particular, I need my constants on the right, so I could add the 2 over here anyway. So this would be y equals 1/2 x plus 4. But I need the x term on the left, so this is negative 1/2 x to both sides. So I've got negative 1/2 x plus y equal 4. And here I have to tell you that I kind of haven't been completely honest along the way. There are in fact some conditions on A and B in order for this to be standard form. In particular, A, B, and C, whoops, that was C and C, that's weird. A, B, and C are all whole numbers, so no fractions. And A needs to be greater than 0 or positive. So right now A is negative, and it's also a fraction. So what am I going to do? Well, I can eliminate both of those issues if I simply multiply by a negative. That'll get it to be a positive. And instead of having the fraction 1/2 here, I can multiply by 2 so that I will have the value 1. So if I multiply by negative 2 on the left, I have to multiply negative 2 on the right. So negative 2 times negative 1/2, of course, would be 1. So I have x. And then minus 2y equals, and then I have 4 times negative 2, which would be negative 8. And this would be my slope-intercept form. Not slope-intercept form, but standard form of this line. Okay, very similar question, but it references that we have perpendicular lines. All right, so again, in order for us to work with this, I need to know what the slope is to begin with. So how do I find the slope? I put it in slope-intercept form. So I'm going to subtract, my x to the right. So I have negative 2y equals negative x plus 3. So that's good. And then I'm going to divide by the negative 2 on each term. So this would be y equals, I've got 2 negatives, this would be positive 1/2 x, and then minus 3/2. Again, the negative 3/2 is not very important. The part that is important is this 1/2. So if the slope here of this line is 1/2, then the slope of the perpendicular, so the perpendicular notation is a line with a line at the bottom like this, if you remember, that's perpendicular, would have to be the negative reciprocal. So since this is already positive, that would be negative. And the reciprocal of 1/2 is 2. So the slope of my perpendicular line is actually going to be negative 2. All right, so I have negative 2 slope. I have a negative 3, 1 as my ordered pair. So I have y minus the y1 value, which is y minus 1, equals m, my slope, which is negative 2, times x minus, and I've got negative 3. So y minus 1, I'll distribute the negative 2. So this is negative 2x. Minus the negative 3, that's plus 3. And then plus 3 times negative 2 would be negative 6. Okay, so I'm distributing the negative 2 to the opposite of negative 3. I'm going to move the constant to the right, so I'll add 1. So this is y equals negative 2x minus 5. And then my x is supposed to be on the left, so I'll add the 2x to the left, and I end up with 2x plus y equals negative 5. And this is actually in the slope, or in the standard form that we were asked to put it in. The a value is positive, and a, b, and c are all whole numbers. So we're stopped at that point. Our last example is something that is perpendicular to x equals 7. Now I can't get that into the form, y equal mx plus b like I have on the previous two, because there is no y. But what you should, again, notice is that if you have an equation that says x equals a number or y equals a number, then we have either horizontal or vertical lines. Because this is x equals, that would be the VUX, right? X equals, I have a vertical line. So if you think about having a vertical line, that means it's straight up and down like this. Then in order to get a line parallel or perpendicular to it, it would have to be a horizontal line. So the horizontal line that I'm going to create is the HOY part, H-O-Y, of HOYVUX. And horizontal lines have equations y equals. Well, what does y equal? Super easy. It's the y value of the ordered pair, 2. Y equals 2.